Hello class, these are our notes for Algebra 1, Section 217, Types of Linear Systems and Solutions. So today we're going to be talking about some kind of special cases here. So we're going to solve by both graphing and elimination. So let's go ahead and graph first. If I have 3x plus 2y equals 10, if I try to do my standard form graphing where I find x and y intercepts, if I make my y equal to 0, I have 3x equal 10, and that's a fraction, right? And it's very difficult, especially when we're trying to graph a system of equations and get it to come out exactly right and tell where our equations cross. It just doesn't make sense. It's not an accurate way to graph. So instead what I'm going to do is I'm going to solve this for y. I'm going to subtract 3x on both sides. So 2y is equal to negative 3x plus 10. And then I'm going to divide through by 2. Remember, we're distributing that division to everything. So y equals negative 3 halves x plus 5. So let's go ahead and start at 5. And down 3 over 2. And then we want to make sure that we go ahead and just connect that line here. Whoops. Sorry about that. All right, for my second equation, I want to do the same steps. So I'm going to subtract 3x on both sides. 2y is equal to negative 3x plus 2. And then I need to divide everything by 2. So this is really interesting because I end up with the same slope, but this time my y-intercept is 1. So let's think about this, what this really means. So the slope is like the angle of the line, right? That's my rise over run part, but I have different y-intercepts. So it's still down 3 over 2, but instead of starting at a positive 5, it's starting at a positive 1. So I end up with some parallel lines. And when my lines are parallel, it means that they never cross, and so we have no solution. So lots of different things going on here that we want to make these connections with. So our lines are parallel, we have no solution. Could I have figured out that my lines were parallel to start with? Absolutely, because both of my lines have a slope of negative 3 halves, but I have different y-intercepts. So I absolutely could have figured out just by kind of looking at those equations and rearranging them that that's what I was going to get. So we want to take one more step here, and we also want to try solving with elimination. So that's going to mean erasing a bunch of this algebra work that I already have. So let's go ahead and do this. And then if I am solving with elimination, I would want to multiply one of my equations by a negative 1, because I already have a positive 3x. That would give me a negative 3x as well. And so that means I have a 3x plus 2y equals 10. And my second equation would be a negative 3x minus 2y equals negative 2. So what I've done here is I have multiplied all the way through by a negative 1. And so when I add together, my x's are eliminated. That becomes a 0. My y's are eliminated. That also becomes a 0. So I have just 0 on the left-hand side. On the right-hand side, 10 minus 2 is 8. So because 0 does not equal 8, I also have no solution. So I could get this answer algebraically by working it out or graphically. So it's really important today. We're trying to get these connections between all of these different things. So looking at our next problem, we're going to solve by graphing again and elimination. So first over here, I want to start by graphing. If I am finding my x-intercept, I am letting my y equal 0. That means I have x minus 2 times 0 equals negative 4. So that means that this whole part here is going to zero out. 2 times 0 is just 0. So x is equal to negative 4. Because my y was 0 and my x was negative 4, that's the ordered pair, negative 4 comma 0. It is my x-intercept. All right, now I'm going to find my y-intercept. To find my y-intercept, I am going to let my x equal 0. That means I have 0 minus 2y equals negative 4, which means negative 2y equals negative 4. Divide both sides by negative 2. It means that the y is equal to 2. Because I let x equal 0 and solved and got y equals 2, my ordered pair is 0, comma 2. That is my y-intercept because it's on my y-axis. And then I could go ahead and graph those two lines. So then I want to look at my second equation. My second equation is y equals 1/2 x plus 2. So I have a y-intercept of positive 2. Oh, that's interesting. Same y-intercept. And my slope is 1/2. A 1/2 slope means I want to rise up 1 and 2 to the right. So up 1 over 2. And it turns out I have the same line. So if I have the same line, it means everywhere on that line is a solution. And so because we have the same line, we would say many solutions, or infinitely many, because any point on that line is a solution. So let's do our best to solve algebraically on this as well. So for this one, I know it says solve using elimination, but I don't know that that makes the most sense here. I do think because it's set up, we have y by itself, that really we're set up for substitution. So I'm going to take this expression for y and I'm going to substitute it. So I have x minus 2, and then instead of y, I'm going to use that expression, 1/2 x plus 2, and then that is going to equal negative 4. I'm a little concerned about that x there not being neat enough. So I have a couple things going on here. This x is going to stay by itself, but I do have to distribute the minus and the 2. So I'm going to be multiplying by 2 and changing my sign. So let's see, that means 2 times 1/2, well that's 1. So minus 1x, that's minus x. And then minus 2 times 2 is 4, equals negative 4. X minus x is 0. So 0 minus 4 equals negative 4, which means negative 4 equals negative 4. Because this is always true, we would say that there are many solutions. So any xy ordered pair on that line is going to be a solution. So last one, it's to solve by graphing and elimination. And just to add one more connection, when we look at these two equations, we ended up with the same slope and the same y-intercept. And maybe that's not easy to see. So I think what we're going to do is we're going to take this first equation here where we found the x and y-intercept, and instead we're going to think about what if we had solved that for y instead, just to prove that they're really the same equation. So x minus 2y is equal to negative 4. So I want to subtract x on both sides. So negative 2y equals negative x minus 4, and then divide everything by a negative 2. So when we divide by a negative, it's going to change our signs. So I have negative, 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 but I'm dividing by a negative. Now everything's positive. When I have this x by itself here, there's really a 1. So we're going to call this a 1/2 x. And then negative 4 divided by negative 2 is a positive 2. So we've really proven that these two equations were the same. So they had the same y-intercept and they had the same slope. All right, next one we are solving by graphing and elimination. So this one I can just tell already, look at how nicely that's set up for elimination. We have a 4y and a negative 4y, that's perfect, but we do want to graph first. So I'm going to take 3x plus 4y equals 8, and I'm going to go ahead and solve that for y. So subtract 3x on both sides, so that 4y equals negative 3x plus 8. And then I want to divide through by 4 so that y is equal to negative 3/4 x plus 2. So let's go ahead and graph there. We're starting at positive 2. Negative 3/4 means down 3 and 4 to the right. And on this last one, I'm not sure if I went up 2 or up 3. So let's maybe double check that point. 1, 2, 3, and then 4 to the right. I think that's lined up correctly now. Okay, so for the second one, we want to do the same kinds of steps. If we have 3x minus 4y equals 8, we want to subtract 3x on both sides. And then we're going to be dividing through by a negative 4. So divide by negative 4 all the way through. So now we have y equals 3/4 x minus 2. Really close, but not the same line. So this one's going to start at a negative 2. And it's going to be up 3, 1, 2, 3, and over 4. So I get something like this. It doesn't cross at a very nice point. So let's go and see what happens with algebra here. When I add them together, my y's are going to 0 out, and I have 6x is equal to 16. Divide both sides by 6. So x equals, let's see if we can reduce this. Divide the top and bottom by 2 to simplify our fraction. And we have 8/3. That is, if I think about mixed numbers, 2 and let's see, 3 divides into 8. How many? Let's see, there's twice, and we'd have 2 left over. So 2 and 2/3, which makes sense here. If you look, it's not exactly at a point that's easy to read. And then if I know my x is 8/3, well, 3 times whatever x is plus 4y is going to equal 8. So 3 times 8/3 plus 4y equals 8. So 3 times 8/3 is just 8. And then we would subtract 8 on both sides. So 4y equals 0. Divide by 4. And y is equal to 0. So our solution is going to be 8/3, comma 0. All right, so for our next section, we're looking at just some things that we found, some commonalities with our equations. So when we had no solution, let's go back up to the top. So the no solution meant that we had the same slopes and we had different y-intercepts, right? We started one of them here, one of them here, but they both had a down 3/2 slope. So let's go down the page and add that piece in. So when we had no solution, our slopes were equal. Our y-intercepts were not equal. And when solving, we had a statement that was not true. So we had a false statement. So we had like 0 equals a number there. So it looked like a no solution. Many solutions. Well, for many solutions, what we found is that our slopes were equal and our y-intercepts were equal. We had the same line. So this was same line. This first one was parallel. And when we were solving, we had a true statement. True statement. For the last one, when we had one solution, what happened is that our lines had different slopes. So different slopes. When solving, we get an xy ordered pair. And it turns out here that the y-intercepts don't actually matter. So if the slopes are different, lines are going to cross. If we think about the picture, this is going to be 2 lines that cross. This is where we have one line and the other line on top of each other. And then the first one, of course, is our parallel lines, just to give us a little bit of context here. So lots of interesting connections that we're forming today. So at the bottom of the page, our goal is to, without solving, just figure out how many solutions there are. So in this first one, I notice my slopes are the same. In the second one, I can see with a little bit of work, the second equation is y equals 3x plus 2. And so my slopes are the same again. So we're just looking at pieces of information like that. So the first two, the slopes are same, the y-intercepts are different. We know that's going to be no solution. And it's totally fine to pause and try these on your own and then go back and get my explanation. I can see 6 and 7 are already in y equals form, so I'm going to jump to those. Here I've got slopes equal and y-intercepts equal. The second one, all I have is a y-intercepts are equal. So on this one, because my slopes are not equal, my lines are definitely going to cross. I'm going to have one solution. And I'm not actually solving here. For number 6, if both my slope and my y-intercept are equal, then it really means I have the same line, and so I have many solutions. For problem 5, I'm going to go ahead and rearrange my second equation and solve it for y. And then I'm going to divide everything by 2. So y equals 3 halves x plus 4. So it turns out my equations have different y-intercepts. So if they have different y-intercepts, we know it's going to be one solution. I also have to do work on 8. My first equation needs to be solved for y. So I would first subtract 6x on both sides. And then I'm going to be dividing everything by -5. So I have y equals 6/5 x minus 42/5. Again, my slopes are different. So if my slopes are different, it is one solution. For our last row, let's see. I need to do some rearranging again on number 9. So 2y is equal to -4x plus 10. Divide through by 2. And I can tell this looks familiar. -4 divided by -2 is a -2x. 10 divided by 2 is 5. So it turns out my equations have the same slope and the same y-intercept. Since everything is the same, it's really the same line, so I have many solutions. For 10, I would rearrange my second equation. And so I have y equals 6x plus 1. And then again, we have the same slope. We have the same y-intercept. And so we have many solutions again. For our last problem, I would need to take my first equation and rearrange. So I want to subtract 3x on both sides. 4y equals a -3x plus 18. Divide by 4. Y is equal to -3/4 x plus 9 halves. So different slopes here. And remember, whenever we have different slopes, our lines are angled differently. They will not be parallel or the same line. And so they're going to cross, and we have one solution. So hopefully you got the big connections today. I think the important part is maybe not this part at the bottom, the analyzing part when we're looking at systems, but just these connections between what our graph looks like and then what that means about our slopes and our y-intercepts, what kind of lines we have, that we have a false statement that there's no solution, kind of putting all those pieces together between the graphs and the equation solving and how those are related. So as always, if you have questions, please make sure that you're asking for help.